So so guys, I think we got interrupted due to the OBS. I think OBS just crashed and just stopped the streaming. I don't know, it stopped streaming or just closed the OBS. Let's check YouTube for that. I just started live or oh, so yeah, this is the live, and few minutes ago we did, but we got interrupted in the middle. So currently this is the live. I don't know what's this humming sound coming from. Let's continue. Let's continue. Close this out and so let's continue with this. So actually we are gonna find the total charge. I think we have to add something more about this point. Should I don't know if I add or not. So I think we should add Q enclosed. Yes, this is much better. Let's delete this part. So yeah, we just multiplied with we will integrate from 0 to r. That way we will find the charge from origin to point P. So we should put a small array, and this is the density complete part, and as you can see the density is given the problem, and this is the volume part. So we can add actually one more line for that. That way it will be quite clear, I think. So let's say Qi, that means Q enclosed, is equals to 0 to r. I think yes, we should accept yes, 0 0, and then we can put small r, and from that rho times dv. So dv will be like this, and then after we can put in the second line the actual values. So yeah, this is okay. 4 pi r squared here is the volume really, and then after we can proceed. Let's put this line in parallel. Yeah, let's continue. So let's accept the comparison and see what it will do. So yeah, but I think it did the wrong calculation. So we have to do little more thing, or is it right? I don't know. Yeah, it integrated, but from where this 4 came, and 3 must be gone. This is the problem with Copilot. Actually, you never know which is right or wrong, so you have to manually check actually most of the time, and this is pretty bad. From indication we can take out the pro thing as well as the pi. We got the pi, and we can multiply this 4 thing inside the so leftward we will multiply for this will be gone, that means 3r square will be okay, 3r square minus if we multiply 4, that means we will get 4 r cube upon capital R. Now 4 r cube and upon capital R, yes, upon capital R. I think that's correct, yes. And then we can use dv part, sorry, dr part. So let's run it first. Yeah, this is correct. We did right, and then after we can integrate in the next line. Let's accept for this part. I think we will use r cube upon 3, 3 will go on, 4 will be gone, and r cube, and then we can put actually right, yes. Wow, this time it just no. Let's say vert. Vert means I think vertical line. So this is a small right vert should be there. There's a no. So what will be the command for big vert? Let's say big. Sometimes yeah, it works. I don't know. Let's call it. What is the command in latex for big right vertical line in Elysian line environment? Yeah, this is what I want. So for that we have to yes big or what. So yeah. That's why lattice is tricky environment. Again, it doesn't work. R word. So what should I do? R word is not working. I don't want to put left vertical line. This way it will just destroy this word. Yes. Let's say right word. What do I mean? Let's say right, and then what? No, again it's not working, and in that case we just have to I just put bracket. I think this way it just does the job perfectly. But once in a while you have to experiment and go accordingly. Be missing somewhere row naught. Yes, so this is row naught. Yes, row naught, and now we will get the proper solution. So now we can just replace with parenthesis instead of the angle bracket, square bracket. So yeah, this is the required charge, and now we can apply the Gauss theorem. So let's start with the intertext. Apply the Gauss law. So for that, yes, that's right. Wow, let's run it first. So I think it's quite good, as you can see. Yeah. So as you can see, I think it got the right answer, and this is done. So yeah, this is the right answer. So as you can see, I'm not going to explain the full physics part because this is the latex tutorial, but I'm going to explain a little bit. So this was a solid sphere part, and we have to find the electric field at this point. So we just firstly find out the charge within this region, and then after we just applied the Gauss theorem for this region, and we got the electric field at that point. Let's move on to problem second. I think problem second is already explained, but let me explain a few ideas around this. So as you can see, these two masses are equal, and both these masses are revolving around a common center, and you actually don't know about the common center. In the problem, we just have the two identical particles, which is in the action of their mutual interaction only. So due to mutual interaction, we got a tangential component. It will start circular motion, and circular motion will provide an extra component called centrifugal force away from the center, and towards center this will get a gravitational force, and whenever these two forces will get balanced, the system will be stable. So there is a question arising, how we can find out the center of this system, or we can say about which point this mass will perform their circular motion. So for that, we just have to stand the system. As you can see on this, on the system of these two particles, there is no external force. That means that the center of mass will never move. That means that only the center of mass of the system will remain constant, and the point about which these two bodies will rotate, that point will remain always constant, and that is why we shows the center of mass for the system about which these two will rotate. So as you can see, we just balanced these two forces. So this will be the gravitational force, which is gm upon r square. For that, this is the radius. So gravitational force will depend on this distance, which is the diameter for this system. That means twice of it. And question is like mass is rotating with a radius a. That's why we took twice of a as the diameter. And centrifugal force will be ma omega square, yeah, mr omega square, and the radius is a, and we got the omega of the system, which is option number C again. So yeah, this is how we got the problem number 2. Let's move on to problem number 3. Problem 3 is quite easy, but you have to assume a linear equation. As you can see, in an experiment, the resistance of a material is plotted as a function of temperature, and as shown in the figure, is a straight line. So as you can see, this is log of RT. R is a function of temperature, and again 1 upon T square. So we can get a linear relation between these two, and then after we can integrate with the proper limit or like that. So let's start solution. So yes, start, as you can see, it's giving the proper solution. So begin center is not the idea. Begin aligned is, oh, where is K coming from? Of align. So let's indent this align part, and it would mean we have to firstly decide something according to the graph. So let's first add intertext. Intertext is not important, but for other people it's important, because whenever you give the solution to other, he or she should know from where you are writing the equation. For that you have to just describe a little bit. It's not chemistry or other thing, so we are going to describe it in a single line, that will be enough. So from plot, from graph, we can see that there is a linear relation between log r and s, this right. So as you can see, and then after we can start analyzing this linear part. So let's we have to continue with r and r naught. So r naught will be what is r naught? So let's say r naught. R naught is we say the resistance at 0 temperature. So it's using by is equals to mx plus c. I think we can do much better. Let's use few more lines, then it will get pretty easy. So add into text. From the from here we should start this, but I don't know exactly. I think let's say at t is equals to I don't know. From here we can start this part. How should I relate linear function? Log r naught. I think let's leave this part. I think we should just move on to equation part. That will be much better. Yes, log r 1 upon ln. But I think we can include this k times slope. Slope is not defined actually here. So negative slope is, let's say, minus k, minus m. M is the slope, and from here we can move on. Ln r is equals to minus m times cs mx plus cs. That's right. And then let's see. So r and I don't think let's firstly modify a few more things. This is r as a function of temperature, so we can add little thing, and then add as a function of temperature. This is right, and then we can, I think, subtract or something. So slope will be r naught upon, sorry, slope will be I think we have to add few more things. I think here we have to add into text. Yes, here slope m will be like T naught. Let's say T frac. So ln of R of let's say R naught, because R naught is R naught, and then after we can add again T frac. It's quite tedious, but anyway we have to do it. So T naught cos square, yeah. Let's run it first and then we can check out. So yeah, here slope m, here slope m will be I think minus because slope is negative here. So like this. So this is how we can manipulate after that part. So let's, yes, this is what I wanted. So as you can see LNT and everything is got sorted out, I think, and plus C is quite right. Let's move on to second part. So yeah, this got the upper hand, and I think something is not right. T naught must be above the T square. So D fraction, no, this is not right. Or it took the common. I don't know. It should take the common. I don't know what's going on. It's wrong. Yes, we should take the common from the okay guys, I'm going to join a meeting, so for that now we have to stop this live streaming session. I will be joining pretty soon, but I think after an hour or so. So we will continue right from there. So yeah, thank you.